Hey everybody, welcome back. We're working on activity 4.4 mathematical modeling today. This video feels a little bit overdue. Sorry about that. It's been a while since we did a video. Well, that's not exactly true, but you can always do more, have more fun. I know I'm loving it. I think you're going to be loving it so much. We'll see. I might just be fending off requests for more practice problems over winter break. I don't know. We'll find out. Anyways, what we're doing with this mathematical modeling is we are trying to analyze data and then use that data to make predictions. So right here, what we're going to be looking at is the mean annual rainfall over an area and the average annual runoff from an area. So let's copy and paste our data over, either by highlighting, copying and pasting, or by just typing it in, whatever you can get to work. And then let's clean it up and we'll talk about what it means and how we're going to analyze it specifically. So to change the first thing we're going to want to do is change these right here, the widths of each column. We're just going to use this arrow to slide it over till we can see everything right there, and that looks good. And we'll go a little bit further up right there. Nice. Okay. Now let's center our data so it's a little bit more readable underneath its label right there. Perfect. Okay, just to keep it consistent, let's go ahead and fix that. And I'm going to change this a nice color right here. It looks pretty good. I kind of am fond of this purple. Oh, you know what? That wasn't what I wanted to do. Control Z, let's do the fill. The fill looks really good. Yeah, there we go. That's a little bit too dark. One more time. Here we go. Let's try this one. There we go. Nice. Okay, so now our data is looking good. We're ready to talk about it. We're ready to analyze it. We're looking at the mean annual rainfall over an area. So that's basically how much rain is coming down and hitting the surface of the earth, right? So inches means that if we had a tarp on the ground and we dumped all of the rain from the whole year onto that tarp, it would be 40 inches thick. That's a lot of rain. That's a lot of water. Obviously, it's falling over the course of the whole year. So, it gets spread out. It doesn't get that thick. But you see floods and stuff happen when lots of inches of rain fall at once. One thing that can help us predict floods or talk about pollution is the runoff of water. So if you're not quite familiar what runoff is, let's just run a quick Google search here, runoff. And we'll take a look at some images that kind of help explain it. Looking at this, you can see it's water that, doesn't get soaked up into the ground and it ends up running off. It can go a variety of places into the city where it goes into drains usually, or it can run off over the land and into streams. And this can cause some problems if there's a dairy farm here, or, a farm that's using a lot of pesticides, a city, there's motor oil, all kinds of stuff around. That can cause, pollution to run into the water and then into the streams and rivers. So that's why we might be concerned with runoff. Also, for flooding reasons, stuff like that. Keep in mind some of the water, or in fact, much of the water soaks into the ground and then it re-enters the stream later down lower, or, it just stays there. Who knows what happens in the ground? Well, we do know what happens in the ground. I don't know what I'm talking about. Okay, you get the idea of what a runoff is. We'll keep going with the data analysis, what we're really here to talk about. So how we're going to do it, we're going to decide which one of these is the independent variable, which one's the dependent variable. And right now, we will explain a little bit more about that later. For now, let's just go ahead and highlight the data, and we'll go to Insert Chart. And we're going to choose a chart type of Scatterplot. Okay, now this looks good. The data is coming from right here. So if we need to make adjustments, we can see the data range right here, B2 to C8. If I do something like this, if I do B2 to B8, and then I hit enter, it's going to look different because now we're just taking column B and putting it in there. So you can see there's no x-axis, and we only have column B data, right? 40, 24, 30, right? And so on and so on. Okay. So let's get our other column back in here. Now, I promised we would talk a little bit about the independent versus the dependent variable. Oh, interesting. Now we're looking a little bit different because we have a different type of scatter. We have both data types. We need to merge them into one. How are we going to do that? Use row 2 as headers, use column B. Switch rows, columns. No, that's not what we wanted to do. Okay, use row 2 headers. Nope. Use column B as labels. There we go. Okay, so use column B as labels meant we were designating this one to be the x-axis right here, B2 to B8. That is our independent variable. In order to have any runoff at all, we have to have some rain falling first, right? The rainfall really controls how much runoff there is, because if no rain falls, there's no runoff. More rain falls, there's going to be more runoff, right? Makes sense. Okay, so this is our independent variable. That's on the x-axis. This one's the dependent variable, the runoff. All right, so let's get back to editing our chart right here. We'll just click on one of these and we'll get our whole window back here. Our data looks good, so let's go ahead and add on some titles here for the chart. I'm going to call this let's see, let's call this rainfall and runoff right there. Keep it simple. Then we'll use this drop down menu right here. The horizontal axis is average annual rainfall. This is for the horizontal axis, and then we'll use inches squared, and that looks good. Now we'll put on the vertical axis title, average annual average annual runoff, again, inches squared. Perfect. Average annual runoff, average annual rainfall, both of them in inches squared. Looks good. The last thing that we're going to do is add a trend line to our graph here. So let's go to click on series right here, and we will add a trend line by clicking right here. And you can see now we have a line that goes through kind of estimating the center of our data. This is calculated using the variance and the standard deviation right here. Okay, so linear, we want a line type instead of, rather than like a parabola or, you know, an x cubed, some kind of exponential function, right? We want a line right here for this one. You can change the opacity, the color. Let's choose, you know, something like a green, make it a little bit darker. That's looking pretty good. I like that. Linear, you can change the thickness. And we do want to add the label. We're going to say use equation right here for the label. And we're going to show the r squared value. The r squared value is essentially, let's see if we can format this so it looks a little bit different. Perhaps we can't. Oh, well. We probably could, but maybe it's not worth it. The r squared is a value that says how good of an estimate do you have. It's a value in between -1 and +1. I believe the closer to 1 you are, the better of an approximation it is, the more sure your data kind of follows this trend line right here. So we can see our trend line 0.619 times x plus -9.78. All right, there we go. So we have our graph. Now we're going to use it to make some predictions, and we're going to first answer some questions, make sure we really understand what's going on here. So we're going to copy this. I'm going to use Control C. You can also go to Edit, Copy, and we're going to come over here to our sheet here, and we're going to paste, our doc here, and we're going to paste it in. I'm going to use Control V. Now it says link to spreadsheet or paste unlinked. I'm going to leave it linked. That way, if I make a change here, like if I change one of these data points, I say, oops, Red Bank Creek, we read the gauge wrong. We better change it to, you know, 25. You can make that change, and this will be affected, right? It will change to 25 right here too. Okay, so I'm going to paste it in. That looks good. Now we're going to go through and answer some of these questions right here. 0.619. Okay, so the first question says, rewrite the equation of the trend line using function notation where R of W represents the annual runoff and W represents the annual rainfall. That makes sense. So R for runoff, maybe W for water or something like that. So we're just kind of rewriting our equation. I'm going to go right here to insert equation. And then I'm going to click new equation right here. And let's see if we can do this. Let's say R, did it work? Okay, R W equals, and let's see what we want. 0, we'll put it in parentheses, 0.619 minus, let's see, what was that? The y-intercept, negative 9.78. 9.78. Perfect. And do we have our space equal? We know we need a space there. Okay, good. Now there is our equation. It looks pretty good when we use the equation builder right here. So this kind of makes sense. Oh, you know what I forgot? Wow, that was silly. I forgot to put the variable in there. W. Okay, good. So basically we take the amount of water that falls onto the land, we multiply it by 0.619, and we subtract 9.78. Now we're going to answer question B. What is the domain of the function? That is, what values of W make sense? Explain your answer. So there's certain values of rain that you just can't have. I'm going to let you figure out what they are, and then the domain is going to include only values that we know can occur or that make sense to occur. Okay, so let's again use the equation builder, and I'm actually going to use function notation here, which uses either parentheses to contain our range of values, or we use a bracket. A square bracket. We use a bracket when we want to include the number at the bottom. We use the parenthesis when we don't want to include the number at the bottom or top. So for instance, if 0 is possible, we're going to use a square bracket. If 0 is not possible, we're going to use a curve bracket. Okay, so I'm going to put mine in there, 93 to infinity, of course. Right there, 93 to infinity. That is our domain, and then we're going to just put some kind of explanation of why that's in there. I'm going to put souls or somebody like that, something like that. Okay, what is the range of the function? Explain your answer. We're again going to think about what values for the y, so what runoff values make sense. The domain is for the independent variable, so we were thinking about what rainfall values we could have. Runoff, we're going to think about what runoff values we could have. Going to explain our answer. What is the slope of the trend line? The slope is 0.619. Explain the interpretation of the slope in your own words. This means as the rainfall increases, the runoff increases, but or maybe not but, increases, let's just leave it there. You can figure out what to add after that. Estimate and we'll move on to letter E, estimate the annual runoff amount if the annual rainfall amount is 54 inches. So how much runoff do we have if we have 54 inches of rainfall? Now, we've been just doing it by looking at the graph and estimating. That's a pretty good way to go. It's not the most precise way. That would be kind of like a level 2, maybe level 3 way to do it. This is more like the level 3, level 4 way to do it, where you actually calculate it, figure it out. But we're going to we'll use that to get us an estimate, right? And then we can check it later. So let's see. So this goes by 5s, 40. So our inches of rainfall, we're looking for 54 inches. So we're going to go 40, 45, 50, 55, and then back it up a little bit to 54. And then we'll go straight up from there. We'd probably intersect around there. This looks like, to me, I'm going to say 24 inches of rainfall is going to be my estimate right there. Pardon me, 24 inches of runoff. So we'll say est 24. Okay, good. Now let's actually just go ahead and calculate it using the function builder and just, and plugging in 54 inches. So this will give us the precise value. So let's use an equation, R of W. You know what, maybe I can just copy it, but this is probably just as fast. 0.619, 0.619 times W minus 9.78. I think those numbers are right. Let's double check. 9.78. Okay, perfect. All right, that looks good. Now we'll do another line, and we will put in a new equation, substituting in 54 inches. So we have R of 54 equals 0.619 times 54 minus 9.78. Okay, good. And then we'll just calculate this. So I'm just going to grab this and highlight it and type it into Google and see if it'll just figure it out for me. Multiply 54 times that, subtract that. We'll see if the calculator works. Oh, good. Okay, that seems reasonable. 23.646. I think I'm going to round that to 3 digits because if we look at our data, we kind of have like 2 digits right here, is 3 sometimes. So we probably shouldn't keep all of this precision right here. So I'm just going to go with 23.6 and let's see, let's paste it in right here. 23, oh, that got a little big. All right, let's just use the equation builder again, 23.6. Perfect. And then we could say inches of runoff. Okay, I'm happy about that. So it looks like our prediction was pretty close, right? We guessed 24, it's 23.6. You know, if we rounded it, we could even say 24 inches. So there you go. That's using the equation to calculate a prediction for the runoff based on the amount of rainfall. There's one more of those for you guys to work on your own, and then a whole other graph and set of questions for you to answer. Thanks for watching the video. Good luck.